How to use SelfCAD's new sweep tool. You can find the sweep tool in the Tools section, just after the Follow Path tool. The sweep tool incorporates many of the features available in the Follow Path tool while introducing several new capabilities. It also addresses some of the limitations of the previous tool, making it easier and more efficient to create complex shapes and workflows. In this video, we'll show you several examples of where this tool can be used and why it's such a valuable addition. We'll begin by creating a simple path. Let's draw an M-shaped structure. Press Escape key to finish drawing. Next, deselect the design so we can create a new profile. We'll create two different profiles to demonstrate different use cases. First, use the Circle tool to create a profile with a 25mm radius, then deselect it. Next, use the Rectangle tool so we can compare the results using different profile shapes. You can also create this using the Follow Path tool. Select both the profile and the path, then click Extrude. If we switch to the bottom top plane, this is the result we get. Now let's see how the new sweep tool works. Open the sweep tool. You'll notice there are two modes. That is, exact and solid. If we preview the exact mode, the result is essentially the same as the Follow Path tool. No additional settings are applied. It simply follows the path exactly, producing sharp edges where necessary. The biggest addition is Solid Mode, which is one of the newer solid modeling features introduced in SelfCAD. Similar solid-based functionality has also been added to tools like Chamfer, Fillet, Add Thickness, and several others. Select Solid and click Preview. It takes a little longer because SelfCAD needs to calculate the geometry. Once the preview is complete, you'll notice that these corners have been smoothed out. In this particular example, the improvement isn't very noticeable because the profile is relatively large. However, in many situations, especially when using smaller profiles, the difference becomes much more apparent. If we scale the profile down, the results look much cleaner. On the other hand, increasing the profile thickness doesn't always produce the most desirable result. Let's look at another example. Select both the circle and the M-shaped path, then open the sweep tool again and click Preview using Exact Mode. Notice that the top edges remain relatively sharp, and these curved sections simply follow the shape of the circle. The geometry isn't perfectly smooth because it follows the original profile exactly, creating a faceted appearance. Now switch to Solid Mode and preview it using the default settings. After the preview is generated, you'll notice that the edges become much smoother. Again, because we're using a fairly large profile, the difference isn't dramatic. However, if we finalize the object, you can clearly see that Solid Mode creates smooth transitions instead of sharp edges. If needed, you can also increase the smoothness of the original profile before performing the sweep, which will produce different results depending on the shape you're using. Solid Mode doesn't simply follow the profile exactly. Instead, it creates a smoother, spline-like interpretation of the geometry, producing a cleaner and more organic result. However, that's not even its biggest advantage. Let's look at a situation where Solid Mode solves a problem that wasn't previously possible. This time, we'll use a different type of profile. Instead of using an open profile, we'll create a simple mesh-based shape. Using the Spline tool, draw a shape where different sections overlap. If we use the Follow Path tool, or even the basic sweep mode, the resulting geometry follows the path exactly, creating overlapping faces. This produces non-manifold geometry, which can cause problems during editing or 3D printing. To demonstrate this, open the sweep tool and preview it using Exact Mode. The preview looks acceptable. However, once we finalize the object, delete the top face, and switch to Solid plus Wireframe View, you'll notice overlapping geometry inside the model. This internal geometry makes the mesh non-manifold and unsuitable for many applications. Let's delete the object and repeat the same process using Solid mode. Preview the model and wait a few seconds while SelfCAD calculates the geometry. Instead of following the original profile exactly, Solid mode generates a completely solid object with smooth transitions. After deleting the top face, you can clearly see that the interior is completely solid, with no intersecting faces or overlapping geometry. The resulting mesh is clean, manifold, and ready for further editing or 3D printing. This is where Solid mode truly excels. Notice that this surface is completely curved. Normally, you wouldn't be able to select it as a single polygon. The reason I can select it here is because I increased the selection tolerance. If I reduce the tolerance back to 0, you'll see that these aren't individual flat polygons. They're true curved surfaces. As a result, it's difficult to select multiple faces at once because the geometry is no longer composed of large flat polygonal faces. Let's finish with one more example using the circular profile. Select both the circle and the main path, then open the Sweep tool. Choose Solid mode and click Preview. The result is a very clean, smooth model. Now let's use the Cut with Plane tool to slice it in half. Set the offset to 20 millimeters, then click Finalize. Hide one half of the model. Looking inside, you can clearly see that the object is completely rounded with no overlapping or problematic internal geometry. If we created the same model using the original Follow Path tool or the exact mode in Sweep, the interior would contain multiple intersecting surfaces. Both modes have their strengths, but Solid mode is especially useful when creating complex, intersecting shapes that require clean, manifold geometry. That's how the new Sweep tool works, especially its powerful new Solid mode. Thanks for watching, and see you in the next video.